welcome and thank you everyone for attending today. As you can see here, what we'll be talking about is securing our energy infrastructures using SD-WAN automation. What we hope to promise to do is not say AI or artificial intelligence today. We're going traditional nomenclature here. So let's go ahead and dive in. We have a lot of content to cover today. So speakers today, myself, I lead the industry practice for Cisco, and super excited to have with me today Marcus Smith, who leads up the solutions for both utilities and renewables, and Andrew McPhee, who's leading up our operational security solutions for Cisco globally as well. Taking a look at the agenda quickly. I'm going to do a quick overview of network requirements. Today is appropriate or applicable to all things in the OT space, but we're going to focus for some of the time on distributed energy resources. Marcus's team has put together a validated design for renewables. So although what we'll talk about is largely appropriate for substations and other places in the grid and utility space, we're going to be focusing on architectures that resemble largely the distributed energy space. So as was mentioned, we'll be kicking off a few polls here. You'll see the first one just coming up on the right side. So after I present just talking about baseline network requirements, Marcus is going to come in and talk about sort of SD-WAN, level set us as an audience just generally on the SD-WAN piece. And then Andrew will come in and dive into the specifics on the security side. So moving on to just, how has the landscape changed and why is network automation sort of required here? So I might have a little bit of a lag here. There we go. So things have changed. We've been digitizing in the utility space for some time. It's really been expedited by a number of things. I've called out a couple here. So distributed energy resources and the pervasive rollout of these is requiring two-way power, which is requiring state deep into the distribution grid to create enough telemetry for balancing authorities and so forth. So we've seen a lot of digitization just in the requirement and supporting DERs. And then of course distribution automation is probably the widest scale beyond meter infrastructure, is the widest scale digitization efforts we've seen globally within the utility space. That is largely going to be driven by grid efficiency, things like power factor improvements, creating a better solution profile, improving uptime on things like transformers, et cetera, all the assets that are in the distribution space. And of course, with all of this digitization and connectivity, security is becoming sort of a foundational leg to grid reliability, which is a main component of our discussion today. So if we were going to take a look at, just generally speaking, what is network automation? It's what we would assume it is, right? So it's just the automation of all the aspects of network, right? So it's the configuration, managing, the testing, deployment, and operation of both the physical devices as well as all the virtual infrastructure within the network. And so why did that come to be the better part of 10 years ago? So if we look at the lion's share of network changes are manual, right? And so that manual process is several magnitudes more costly in terms of human power, time, et cetera. And so, as a utility, we're always striving for efficiency, whether it's in the execution of delivery of power or with human resources. And so, that's a main driver. But of course, human error being the number one cause of network outages. Automation is really a driver to improve network reliability, which of course drives grid reliability. And so if we were to take a look at just, excuse me, network requirements, I've called out distributed energy, but of course, these could be, replace this with a substation. So if we're looking at things, I'll just call out a few. So scalability, things that we see on the grid are scaled beyond what IT has seen for most infrastructure. So you can see how automation is a nice intersection with scalability, performance management, performance monitoring. But really, if we hit the next slide here, what we'll focus on is security. So as we have to layer on things that are going to be more and more secure, that security comes with additional layers of configuration, you might say complexity, And so as we get more complexity, the risk of mistakes goes up. And so it's a fantastic intersection to create things that are more secure, but then to do so with automation to abstract out that human error component. And so just, calling your attention to the Slido again on the right here, another question for the audience around some challenges that you might be seeing with deploying distributed energy resources. So we can advance the slide one more. And then, why are we talking, why as Cisco are we talking about SD-WAN as the automation component? We're just super fortunate to have a solid SD-WAN platform and some great market adoption. So with that, Marcus, I'm gonna pass it over to you to just take everyone through just what is SD-WAN and what's that value.
Thank you very much, Jeff. So welcome everyone. Nice to have you on this call. So yeah, we're going to quickly in a few slides just really look at what the high level value is of SD-WAN, and then we'll dive quickly into some of the reference design, the Cisco reference designs within the renewable energy space. So what is SD-WAN really in a nutshell? Before I talk about SD-WAN, there is another poll question open. It's asking about your experiences with your organization, you already using SD-WAN in the OT space. So feel free to answer that question. But yeah, what is SD-WAN really? For those of you that are not familiar with SD-WAN, it's basically SD-WAN provides a virtual architecture that allows companies to leverage any kind of underlying transport service. Could be MPLS, could be LTE, could even be the internet, to provide an overlay network that can securely connect sites and users to any applications. So the tagline is really any applications that are anywhere can be connected to any user. It relies on a centralized control capability, and that centralized control capability can direct traffic across the WAN, which basically improves the application performance and provide security. So that's what we're going to talk about today, is the security that the SD-WAN solution can then bring to that overlay network. So when we're talking about traffic like SCADA traffic, critical traffic in these renewable energy sites, it's about transporting that traffic securely across the network to a control center or some kind of data center. So a few of the common terms that you always hear mentioned with SD-WAN are the underlay network, which I'll mention in a moment, the overlay network, which is in effect the SD-WAN network that we're building, and that is also referred to quite often as a fabric. So if you hear the terms underlay, overlay, and fabric, that's really what we're referring to. The underlying transport network, the overlay network that we're creating with the SD-WAN solution, which we quite often refer to as a fabric. So SD-WAN, really from the bottom up, we're talking about any location. We can connect any location. We have platforms, we have enterprise and ruggedized platforms that we can deploy at any site, and I'll show those shortly. Any transport, so whatever the underlying network is, whether it's an MPLS network, it could be cellular network like 5G or LTE, it could be the internet, that we can use that, any of those underlying network technologies to actually connect our locations to wherever our services are running. So our services could be SCADA services, could be typical IT services. Obviously, we want to move those from the site to either cloud-based applications or customer-owned on-prem data centers. So wherever these services are residing, we want to be able to securely connect from any of our sites across any transport mechanism to those sites. And then deployment. So we support on-prem and cloud-based deployments of the SD-WAN solution. And there's a whole host of features that come along with SD-WAN. So in addition to security, we have guided features around troubleshooting. They rely on some machine learning as well. Lots and lots of network insights for getting visibility of the network. Automation is a key aspect, as Jeff mentioned. So actually onboarding these gateways remotely and actually securely onboarding them and then pushing configurations to them and then managing the life cycle of those gateways as well. So obviously key parts of this solution from an operational point of view. And then the programmability, the APIs, and the ability to interact with the controllers and the SD-WAN solution rather than having to use the GUIs. So there are obviously GUI-based methods to configuration and monitoring on these controllers as well. So from a security point of view, SD-WAN provides us with an integrated security solution. So we have a comprehensive set of security features that are integrated into the Cisco SD-WAN solution. Okay, so things like enterprise firewall, intrusion protection, very common in the renewable energy space. You know, we're pushing these down to the gateways at the edge of the network. URL filtering and things like advanced malware protection as well. Okay, these can be added centrally on the controllers, and then these capabilities can be pushed down to the gateways at the edge of the network. The bottom line is these features built into the SD-WAN solution obviously reduce a lot of the complexity for you as a customer to have separate standalone single function solutions or security appliances. Okay, so the aim here is to make it more efficient, easier to manage, easier to configure as well. One of the other things that the SD-WAN solution provides is obviously segregation of traffic. So that secure segmentation of traffic via inside the solution, what we call service VPNs. So the ability for us to segregate enterprise traffic from SCADA traffic, for example, and then securely transport those from the sites, the renewable energy sites, to control center or a head end. And all of this is obviously, as I said, makes it really easy to deploy these features, makes this solution reliable, but also scalable and flexible. Okay, so we can add one or more of these features to our gateways at the edge of the network. We don't have to actually add all of them. So the physical gateways, the physical boxes at the edge of the network. So at Cisco, we obviously have an enterprise portfolio, but this is the ruggedized portfolio within the IoT group at Cisco. These are the ruggedized platforms that we deploy to our utility and renewable energy customers. So on the left, we have our slightly smaller form factor platforms, the IR1101 and the IR1800. Okay, compact platforms, pretty flexible, have different WAN options built in, single and dual cellular. We also have onboard switch ports, so layer 2 switching ports. The Catalyst 1800 also has a Wi-Fi option built in, so we can deploy Wi-Fi services as well. But both of these boxes are managed by the SD-WAN solution. Okay, so just like our enterprise routers, the industrial routers onboarded and managed by the SD-WAN solution. The platform in the middle is our larger rack-mounted IR8340. So a very capable platform, very popular in the utility space, but we're also seeing it widely deployed in the renewable energy space. Battery storage sites in particular where we're using this platform. Routing, switching, WAN connectivity, all built into this platform as well. Okay, so it's quite a powerful platform and is SD-WAN managed as well. And then finally on the right hand side, we have our full outdoor IP67 rated Catalyst IR8140. Okay, this also has battery backup, so it has integrated battery backup. It's designed to be mounted outdoors in an area where there's no protection, so there's no cabinets or enclosures. It's fully environmentally hardened, but provides the same kind of capabilities, the WAN backhaul and the connectivity, the secure connectivity. Okay, but it's all in an IP67 enclosure, which means it doesn't need protection, as do the other platforms on the left-hand side. So again, at the bottom, the saying, you know, always goes, any platform, any site. So we have quite a range of hardened, ruggedized platforms. that meet the requirements of any type of renewable energy site, either it's its size, power consumption, rack space availability, or the actual hardening of the platform. So we have a platform that can meet the requirements. So we'll quickly now look at the actual reference designs from Cisco before we dive into the security features and the security aspects of this session. Quickly put some context around the renewable energy reference designs. So for solar, so this is grid scale solar, we, on the right hand side, we have a large amount of switching infrastructure deployed to connect the inverters around a solar farm. But really what we're focusing on here today is on the left hand side, which are the ruggedized platforms, the gateways, and the SD-WAN connectivity. So the IR1101 and the IR1800, in particular here the IR1835, both are common platforms we use in the solar space, both managed by SD-WAN and support a number of the security features that we've just reviewed. Okay, so depending on the platform, some of the platforms support a subset of the security features, but for example, the IR1835, it's a slightly more capable platform and supports all of the SD-WAN security features. Okay, so the choice comes down to the security features you want to push to the edge of the network. And then on the left-hand side, you can see Cisco Catalyst Center for managing switching infrastructure. CyberVision, our cybersecurity product, which we'll talk about shortly, and Identity Services Engine, our security policy platform, again, which we'll talk about shortly, can all operate over the top of the SD-WAN infrastructure to manage components and provide access within the actual solar site itself. Okay, so very flexible architecture. You can pick and choose the different components from a security point of view, depending on your requirements. This is onshore wind, so looks very similar, except for we're connecting turbines rather than in solar inverters. Large switching infrastructure again, but on the left-hand side, obviously we're concentrating here on the SD-WAN connectivity, the secure WAN connectivity, and same platform. So the same platforms are applicable for access into the onshore wind locations. Offshore wind is a completely different beast. They are huge infrastructure projects onshore and offshore. So to the right of the dotted line in the middle are the offshore components. These are again primarily switching infrastructure, but on the left hand side, especially on the onshore location, the onshore substation, this is where we will find the WAN handoff point. So this is where we potentially find our WAN routers, and our SD-WAN network will be extending from here. So here there's an example of the IR8340, so bigger platform, more throughput required, but again it's an SD-WAN managed platform. So we have the same capabilities and we can push the same security features down to the edge of the network using the IR8340. Okay, so these projects are usually much bigger, so we do have slightly different choice of platforms when it comes to these type of infrastructure projects. Okay, so that's a quick look at the validated designs. This is a validated design. The previous two are what we call reference designs. This is a fully validated design, and it means it's tested in our labs, and there's a lot of documentation available on our external website for this. Okay, so now I'm going to hand over to my colleague Andrew, and he's going to take us through some more of the security elements in a bit more detail.
Thanks, Marcus. So, hey folks, to start with the security, what normally happens, what we normally find in this, especially in the OT world, but we're guilty in the IT as well, is we typically tackle security with very kind of immediate needs from a capability perspective, and we end up with a patchwork of solutions. So, we speak to customers and they're like, okay, we need a remote access solution. And they go and get a remote access solution that meets their need at that time. And then they decide they need visibility, and again, they go and buy a visibility tool, and suddenly it's segmentation, et cetera, et cetera. And depending on the project that's in hand and depending on the capabilities they have in their kind of immediate needs, they go and buy a point solution. And what's happening from a security perspective is these things are being deployed out into kind of proof of concept labs, and then we go and stitch them all together, and we kind of find out they're not quite working as we intended them to work, and we try to scale them out into multiple locations, and we find it way too complex. What this leads to is shadow IT, in terms of we have really good security in some parts of our network and a really good handle of security in some parts of our network. Then others just get neglected because, you know, the project just kind of fizzed out, or we just weren't able to make it work everywhere we needed to do. And what we've been really trying to do in Cisco is rather than kind of propose bolt-on security solutions and take these networks and try and stitch security on top of them, is how can we get the networking foundation in place and then build security within that network. So as we talk about, you know, SD-WAN and getting that connectivity in place for all of the benefits that Marcus just mentioned, and, you know, getting that automation in place to connect all of these distributed sites, how do we make sure that we do that in a secure way and overlay the security on top of that, and then come back and visit what are the gaps that we've missed and how can we overlay additional security tools to fill those gaps to give us a more concrete solution. And this is an OT focused webinar. But we did mention about, you know, using SD-WAN in the IT, and maybe some of you have SD-WAN in IT and are transitioning into the OT network. The thing about the Cisco networking architecture and all the security products that we bring in, it's the same set of software and tools that we're used to in the IT, but just migrated over to the OT network. So the, you know, foundation of all of this networking equipment is iOS XE. And what we're seeing in the security space, or in the OT space specifically, is it's the IT teams that are migrating to the OT space in order to secure those networks. There may be some instances in which traditional OT engineers have been kind of trained to handle these IT networks, but for the most part, it's professional IT teams that are coming in to work with these OT counterparts to help secure those networks, and giving them the same set of software and the same set of tools that they've already been kind of trained on and used to in the IT side just really makes that transition a whole lot easier. So if we look at the architectures that the Marcus was sharing, I'm going to show, you know, these security features, but where they exist in the network and the purpose that they play in this specific environment. And Marcus flashed up a slide earlier on talking about the security we can do within the industrial routers themselves. So the edge of these OT networks, whether it's the, you know, substation network, whether it's your solar farm, wind farm, wherever it may be, that WAN edge will have a ruggedized router that connects into these SD-WAN networks. And that's the first point of control of what can come in and out of these critical networks. So in this onshore substation, we got an IR8340 that can do the layer 7 firewall to make sure that we can create application rules that can go north-south through that box. We can then layer on top of that with an intrusion prevention system, which is our snort engine that makes sure that no malicious traffic or no kind of traffic with malicious intent can flow through that network. The same level of security and the same level of intrusion prevention we'd have in your traditional kind of IT firewalls can be brought down into your rugged edge. Now, the other features on this list, they will be dependent on the architectures and your use cases, because security does come with a lot of capabilities, and with these boxes, we can do things like URL filtering. That might not be applicable to your network. You know, I saw a question there about doing SD-WAN over internet connections from our substations. It doesn't necessarily have to be internet for it to be SD-WAN, but even if it was an internet connection, as you say, it could be an encrypted communication from your substation edge to a control center, not necessarily going to the internet. And at that point, you'd have your traditional internet security stack at your control center before leaving, if it ever was to leave the control center boundary. But if you are connecting some of these sites directly to cloud services, maybe there's some SCADA systems in place that need to connect to AWS, or you have some vendors that are taking that data, bringing it into their cloud, you can link to things such as Secure Internet Gateway. with, Cisco Umbrella has security service edge and building the IPsec tunnels into a more dedicated security cloud that acts as your web gateway for cloud resources. Takes that burden from having these policies distributed on box all over your network and allows you to just centralize all of those internet-facing policies. Again, it's a rare use case, but some of you may be looking to how to extend these architectures into cloud, and using a secure internet gateway is the recommendation. Now, if we dive a little bit deeper into, what do we mean by this integrated security? What exactly are we getting when we deploy policy on these boxes? The IRA 340 and the 1835 are the two boxes that can run a piece of software called Unified Threat Defense from Cisco. And it's essentially an application that we can run on the box that extends the traditional kind of firewall capabilities into more of a next-gen firewall with malware protection and such. Your traditional iOS XE and any box that we provide that can link into these SD-WAN networks will give you some very foundational security elements, and that may be enough for a lot of the use cases in these OT environments. The attack vector is smaller, especially as they typically terminate at another trusted and controlled part of the network. But just having that application-aware firewall, you can determine, which devices and which subnets are allowed to leave that OT environment. But there's some kind of capabilities that may be a little bit underrated in terms of security. In the security world, we like to focus on fancy buzzwords and the most unique and up-to-date capabilities. But even things such as VRFs, which is the virtual routing functions, the ability to use a single IPsec tunnel, but to segment all of your different traffic into different virtual domains, is still a key security feature today. This infrastructure you're using within the environments may be used to share, it may be shared infrastructure or shared physical infrastructure between multiple different networking domains. You might have some IT traffic that flows through these boxes and some physical security traffic and then some critical control traffic, all need to share that same pipe back to a control center or a data center. By using VRFs, you can make sure all that traffic is separated. And going further again, using that quality of service to make sure that any denial of service attacks could potentially affect critical traffic would be stopped. If someone did manage to get into your IT domain, by using quality of service, we can make sure that the critical traffic always has priority. And this is all just built into your traditional networking stack on a Cisco router. What UTD does, it brings more of those advanced security features when and if needed. So for an example, those of you in the US that have to follow NERC CIP regulations and need to do security monitoring across an ESP boundary typically need some sort of IDS or IPS system. That's where our Snort engine comes in. It can come directly onto those routers and act as that security boundary. And as I mentioned before, URL filtering when and if needed, but also malware protection for any of those use cases resulting in files crossing the boundary. That alternative solution I gave was Cisco SASE or Cisco Secure Service Edge. It goes through multiple different name iterations depending on what marketing is doing every given year or what Gartner is doing every given year, because we just follow what the industry terms are. But this is a way of centralizing security in a cloud model. It's not for everyone. We definitely don't really see it so much in substations, but some of these distributed assets like to centralize their security policies. And this will give you that kind of full-fledged security capability when coming out to cloud resources. What we're not recommending is you put the most up-to-date, or not up-to-date, that's probably the wrong word, all of the capabilities a security box can handle everywhere, because you don't need the latest and greatest, and you don't need, like, say, TLS decryption on every single box if your use case isn't required to do it. So for those more advanced applications, if you can offload that to a security service edge, it allows you to do security at scale without putting burden on the boxes. At the end of the day, uptime and resiliency is your most important feature on a router, and then you want to do the security that is needed on those boxes. And different architectures will occur even within the same organizations. You might have some sites that you want that integrated security directly at the router, and you want to have, best of breed on box. And then there's other sites that you will bring back to a colo, and you'll lose your centralized security stack, or bring it back to cloud security. SD-WAN has that flexibility in place that you don't have to choose one for your whole organization. Certain sites will be treated differently, depending how critical that site is for you, or depending on the use case that each site provides. So multiple different deployment options depending on your needs. Now, if we go a little bit deeper into the architecture, and we go beyond what else do we do beyond just the security we put on the edge, remote access is probably the biggest use case that we talk to everyone about, especially in recent years, where more and more people are working from home, or, as you know, Marcus mentioned, some of these sites are offshore, and to get people physically located, it's time and money and resources. We have a product called Secure Equipment Access that will sit within this network architecture that you can see here, and I'll go into a little bit of detail of what that does and where that sits. So Verizon does a data breach investigation report every year that breaks down the threat landscape of all of the attacks that's come before it. And every single year, it's pretty much the same. The risk from external threats is the biggest risk to your organization. So when we think of security, and someone says you need to secure the network, the very first thing you should be thinking of is remote access. That is the number one attack vector. That's how bad people get into your environment. And then once they're in an OT network, through the lack of segmentation and a number of vulnerabilities, that's how things spread. But that initial access point is typically remote access vector. And with the, Jeff mentioned, I'm not using the term AI. I'm going to use it once, and that is AI makes it easier to do social engineering, deep fakes and faking people's voice and being able to copy the cadence of your text makes it much easier to mimic people, to get you to click on links or share your details with people that you thought were trustworthy but were not. And social engineering is continuously on the rise for those reasons, and stolen credentials are still a huge issue for security. So to handle the remote access use case and the threat of remote access, we are seeing an evolution from VPNs to zero trust network access. Again, another buzzword for the buzzword bingo doers out there. But what we would have recommended in the past from an OT environment, because it's not necessarily wrong to do the version on this left, is to VPN to your network. Hopefully do MFA and not VPN, but a lot of people don't. Colonial Pipeline as an example. And then hit a jump server in the network. And then from the jump server, you would do policies between jump server and the thing that you were trying to access. But ultimately, what you're doing with a VPN is extending the network out to these remote users. And you'll have things such as NERC that'll say, well, your VPN concentrator has to be outside the ESP, and there'd be some boundaries in place. But ultimately, there's a lot of touch points for policy, and it becomes overly complex just to give someone simple remote access to a device. So what ZTNA is putting in trust brokers in your network to facilitate connections to one asset at a time. So rather than the network being extended, you are just brokering a session to individual devices, ultimately not bringing the user onto the network to be able to do things like scanning or lateral movement like they would in a traditional attack. Another version of this is called Secure Equipment Access, which is zero trust network access for OT environments specifically. It was built for OT in mind. And there is a poll question that should be coming up for you now, talking about your cloud usage or your willingness to use cloud, because this is a cloud solution. Remote access is normally one of those solutions that we get a bit of leeway of being, able to use the cloud with too much pushback, because those remote users do come from outside your organization. And in this case, there's a two-tiered approach. So you have the Secure Equipment Access Cloud, which is the user interface for our remote users and, of course, the administrators. But there's also the SCA agent. And I mentioned, how that we're building security within the networking infrastructure itself. This agent would sit on Cisco Industrial Networking and act as that broker for remote access. The point of the ZTNA solution is to broker that connection down to individual assets at a time, and then time restrict when a user can or cannot access those devices. I'll take you through that in the next few slides. So first of all, the login situation. whenever a user is logging into the network, multi-factor authentication should be the very first thing you think of from a remote access capability. The biggest mistake for remote access solutions is just not doing MFA. If you do MFA on your remote access, you will probably stop 95% of the attacks that come into your environment, and it should be the first thing configured on any of these boxes. So from a secure equipment access perspective, we have two ways of doing that. You can do native MFA on the dashboard itself, or the more common approach is you want to manage identities in your own IDP, and we'll integrate into that IDP itself so you can manage it there. But the most important thing is do multi-factor authentication for every login of your remote access. And then from there, limit what you can do once you're on that network. So in this case, you're not actually on the network, but you have limited access to what you can see and do in SCA. So as an administrator, I can give users access to single assets and then restrict them on what protocol they can use in those assets. I might have users who are allowed to view the web application of a device, and then I have more administrative users who can SSH into that device. I can control it down at the protocol level. I can then go take that further and make sure they only access it through maintenance windows. So between August 31st at 11:30 and August 31st and 12:30, you can access it. If you're outside those time windows, you don't get access to that network. So it's time restricted access to individual devices using individual protocols. There's then a client approach and a clientless approach. The clientless approach is a browser session into those devices. So if you want web access to a device, it's just a browser window into that device. You or your own device are never actually connected to the network. There is, though, an agent-based option. So a big barrier to remote access, and the big reason we use jump servers, is to host the third-party applications within those jump servers so they can use them to configure or monitor the network. With an agent-based CTNA solution, we can have the applications run on the vendor laptop, only open the ports and protocols needed for that application to do its job, and then make sure that the posture of that device is checked before allowing that connection to occur. If there's any malware on the device or there's no the endpoint agent running there, they disable the firewall, etc., we won't allow the vendor device on the network if that's the way you choose to set it up. Then last but not least, to be able to monitor and record these sessions. So again, another real strong OT use case. Don't really see this in the IT side, where you bring a vendor into your network and you want to monitor what they're doing in real time. You can look over the shoulder. If you don't like what they're doing, you can terminate that session and then record these sessions for auditing after the fact. So if any incidents that you're looking to investigate that was determined to happen during a remote access session, you could always go back and view that recording to see what happened during that session. So for those of you who said no to cloud, hopefully this changes your mind a little bit. For those of you who said yes, this would be our kind of biggest reason that of those customers who are using the cloud currently in these utility space. Outside of the remote access solution, we then need to understand the security posture of the network itself. So for those of you who are US based, you may be familiar with the direction that FERC has given NERC to do internal networking security monitoring, in which they want to do more monitoring within the critical boundary. So there's a recognition that doing perimeter security isn't enough, and they need to do monitoring within these critical environments themselves so they can respond to threats faster. For those of you in EU, you're going to be hit with the NIS2 compliance, and they'll be looking at things like visibility and understanding the risk of your environment too. And that's where cyber really comes in. Now you can see all of these orange sensors that's been distributed across all of the infrastructure. That is how we do deep packet inspection of the OT network. So CyberVision is an asset visibility and security posture tool that sits directly within the infrastructure itself. Traditionally, when you want this level of visibility, you use a span-based network, because all these tools essentially work the same way. You mirror OT traffic, you bring it to your sensors, you do deep packet inspection, and you understand what is on your network and what it's doing on your network. The key difference with Cisco, again, using the network as your security appliance, is we run the sensors within the application spaces of our switches and our routers, and we can mirror the traffic as it goes through those switches. So we're not in the path. We don't cause any disruption to traffic. We simply can take a copy of that data, put it into our application space, do some processing, and then send application flow back to the Cybervision center, which is another consideration when you're sending it over a WAN network. These sensors can exist within the LAN, and when we just send metadata back across the WAN, meaning we're not putting any additional kind of load or cost on that WAN connectivity. If you do the span-based detection, you're typically doing a lot of mirroring across the WAN, and it adds up in terms of cost just to get the data. What Cybervision looks like and what it does primarily is that asset inventory tool. What exists on my network today? Tell me everything you know about the device, and then tell me everything it's doing to the other device in the network. So again, probably should have picked a better diagram because it's more of a manufacturing example, but a Rockwell controller that has devices reading and writing to its system. And we can see at some point in time, there's a stop CPU command. If we pivot over to that communication map, we can see all the other components in our network that thing is communicating with to understand what is in our network, what is it doing in our network, so we can react to things when they deviate from a baseline. And then from a posture perspective, how risky is that device to my network? So by using all of those device properties, such as, what is the firmware version running on this model of PLC, we can tell you what vulnerabilities have been attached to that specific device, and then use that to get a risk score. Because in your environments, there's going to be thousands of components. It's going to generate probably hundreds of vulnerabilities, and you need a way to prioritize this. So we use a combination of the criticality of the vulnerabilities, the group impact it would have in case of downtime, and that's for you to configure. The activities coming to and from that device, is there any activities that have indicated that something maybe wrong is happening with this device, or something more vulnerable could occur within this device? And we aggregate all of that into a risk score to help you prioritize remediation of these threats. Visibility, though, is one of those things it's great, but what are we going to do about it? In this too, we have to report it. But every time we talk about incident investigation, there's always that response word that comes afterward. What can we do in order to respond to these threats, or what can we do to just put in preventative measures in place? And just like what FERC has mentioned, that doing boundary security is typically not enough, that applies in all of these architectures where we have things like identity services engine that can segment the network further. It shouldn't just be one OT network and one IT network, or this is my OT and this is my control center. If we can carve out that OT into smaller zones of trust, that is a good preventative measure for when things do go wrong, the blast radius is reduced. So Identity Service Engine, to continue the theme of your network being your security appliance, is a way to segment the network directly in the switches themselves. And the IEC 64/3 zones and conduits model is one of those architectures that spans across every industry, whether it's utilities, manufacturing, mining. It doesn't really matter. Customers are always looking to architect to this standard, both from the use of secure components, which Cisco provide with their network infrastructure, but also the zones and conduits architecture to protect the network. And it's a pretty simple set of standards in terms of it just asks you to create a series of zones, which can be a kind of functional grouping of devices or physical grouping of devices. It's really up to you how you architect your network. And then they just ask you to identify the assets within the zone and then put policies in place in the conduit, which is the communication mechanism between two zones in the OT environment. For those of you who are not doing 64/3, NIST Zero Trust guidance is pretty much the same thing. ZTA is about placing individual or groups of resources on a unique network segment, and then using switching, routing, or firewalls act as the enforcement points in between. And you'll find a lot of these standards are practically using the same language. They just change some words around. So whether you're, following NERC, whether you're following NIST2 or 64/3 or NIST, by putting in some pretty basic security principles, which is just carve out your network into smaller trust zones, you're going to be passing these compliance standards most of the way, at least. So for us, when we talk about Identity Service Engine, we talk about a technology called security group tags. And essentially what that is taking that zones and conduits approach and creating a matrix of zones and defining the policies in between them. So, what can the enterprise do between a DMZ? What can a DMZ do between your safety systems, etc.? Is it a permit? Is it a deny? Or is it something in between? And, when we talk about what a security group tag is, and some of you on the call who are familiar with Cisco may call it scalable group tags. So I apologize for that, but I call it security. It is essentially just a tag that we place in the traffic to say what your role in the network is. So those of you who have attended conferences before, like Cisco Live, you'll notice people wearing orange lanyards. They're typically help staff. You might have blue for attendees, black for speakers. I might be mixing these up. Green is another function, but that lanyard around your neck typically tells you what the role of that person is within Cisco Live. SGTs are the same thing. We don't care about your IP address. We don't care about your VLAN for security purposes. We just care about the security group tag assigned to your packet, and based on that determines the role you have in the network. When using the switching as the enforcement mode, all it's doing is saying there's a device from this group that wants to go to a device to another group or the same group. Is it allowed or is it denied? And if it's allowed, we'll allow it through the switch. So ultimately your switch becomes your segmentation point in your network, and a pretty flexible segmentation point in the network, because you're going to have switches everywhere and you can choose which ones are going to be enforcement and which ones are not. Now, in reality, that sounds like, well, that's pretty easy. I just define my zones and I can enforce the conduit. In reality, we don't actually really know how to assign devices into a security group tag. It's normally the biggest challenge of, we can put things down on paper from a planning perspective, but how do we actually assign devices to their security groups? Well, that's where cyber comes in. So to kind of tie this off, and your network is your security appliance, cyber on the switch will tell you what devices are flowing through it, and you can assign groups to cyber. So you can visualize that zones and conduits model within your cyber center. After you've assigned those devices to a group, we can share that context with Identity Service Engine, where you create policies of what can happen between those groups. Cyber will tell you what is currently happening between these groups, so it can help you build the policies of what should go between group 1 and group 2. And then Identity Service Engine pushes those policies back into those same switches. So the same switch that you're using for connectivity is giving you your visibility and also giving you your segmentation of the network. And that's how we end up with this. So if you were to go to any sort of Cisco show or to look up Cisco OT security documentation, you'll come across this journey. And that is just a kind of wrap up of how we meet these sort of compliance standards. So build a good security foundation. You want to build security within the network. You don't want to take a bad network and try and bolt security on. You then want to do secure remote access into those assets, get rid of that number one attack vector, and then just visualize everything that's happening on your network, both from what actually is down there and what is it doing for me and how can I react to threats. Preemptively segment my network into smaller zones of trust, so I'm not dealing with a large blast radius if something does go wrong. And then one thing I didn't really talk about is our integration into XDR. OT shouldn't really be treated in isolation while we try and keep it protected from the rest of our networks as best as we can. We still need to have a full kind of investigation from where that threat may have originated from, such as an email, all the way down to that action being taken. So cyber does integrate into our larger kind of SOC type capabilities in order to give you that complete overview of what's happening in your OT. So with that, I'm going to pass you over to Jeff.
Thanks, Andrew. Thanks, Marcus. And thanks, everyone, for hanging with us. I'm just going to kind of circle back to emphasize a couple points that they both made while sort of intersecting with some of the questions and results that we got back. So first and foremost, I think with Andrew's session, and he just mentioned it a couple minutes ago, and I think one thing to really recognize, in the same way that Department of Defense networks, highly secure networks have done in sort of the non-industrial space, this has been sort of migrated over into the industrial space, and that is, or you could even say things like financial services, where what you're connecting to is their core business, right? The value of accounts and so forth. So that notion of using that network as a security appliance and a security sensor has now been extended out into the industrial space. So being able to use all of the network that extends deep within the substation or into the large switching matrix that supports WIN, all of that can be informing and enforcing security, which I think Andrew is really what the sort of the tail end of your conversation was really emphasizing that. The other thing I'll say is it was a delight to see all these questions as Marcus tried to keep up as he's pounding away on his keyboard. So we have another moment. So if you have another question or two for folks to go ahead and type them in. One other, I want to touch on 2 points that came across as the questions as questions came through to kind of reflect on the answers that we got. So SD-WAN in OT, right? So where are we in the adoption model? So as Cisco comes in and talks to its energy clients, we get asked a whole number of things. So increasingly over the past couple of years, probably, Marcus, I'd say maybe we saw an inflection around maybe 2-3 years ago. As network automation, things were being done remotely because of the pandemic and all those challenges and so forth. So, you know, the enterprise, the folks that are really pressing us for SD-WAN and the OT are often companies that are using SD-WAN and IT, and they've already empirically borne out the benefits of SD-WAN, some of which we mentioned. So speed to deploy, accuracy to deploy, auditability against a golden config, auditability against desired security cluster, these types of things. They've already recognized and seen the benefit in IT, and they're pushing it into OT. So I wanted to, that sort of underscores, I think, the results that we saw in the question, which was, I think it was roughly 50-50. Are folks looking to use SD-WAN in operations? And if they're not already really using it in IT, those aren't the folks that are asking us to come and say, you know, really pushing us to deploy this and have Marcus and team test it and so forth. The other piece, you know, there was a question in the poll, and there were a number of questions that Marcus answered specific to cloud and using cloud in the operational space. And I think, Marcus, you chose to really test this out in distributed energy resources versus, say, the substation first. Is that accurate? If you're off.
Yeah, no, I think so. Yeah. So just to be clear, we do use SD-WAN in the traditional utility substation space, and we have validated that separately in our substation automation designs. What we're really sort of talking about here today is renewable energy, where there's a lot more use of the cloud in renewable energy space. There are many independent renewable energy providers who have actually moved all of their systems up into the cloud. So they're less constrained in comparison to our typical regulated utility customers. So just to make that clear demarcation, you know, we wouldn't expect our typical utility customers to be using the internet for connectivity, but in the renewable space, many of the new renewable energy companies are using the internet for connectivity. Okay, so that's where SD-WAN can really help them with security and securing the access down into those sites. So it depends on the type of customer, but we see in both, yes.
Yeah, and you really you pull out two nuances here. One is just SD-WAN, and you know, if you were to come at this from a telecom perspective, your first thought of SD-WAN is sort of across the internet, balancing full charges and various SLAs across multiple internet connections, right? We're extracting that, particularly if you're in a substation, and really leveraging SD-WAN for the automation of the life cycle of the product, not necessarily looking at WAN circuits and things like that. The other piece you mentioned was we're no longer as burdened around using cloud in DERMS because there are so many remote connections that go into DERMS, whether it's power as a service or a wind manufacturer needing to monitor telemetry to provide a certain SLA. That's why that secure equipment access is such a good fit for things, particularly around wind and so forth. So we're getting the hook here, and so just a couple of next steps just coming up in the next few weeks we wanted to draw everyone's attention to. So Cisco Live EMEA is certainly coming up in the first week of February. There's a utility specific summit. It's about 4 hours or so on the 7th. And there's also a utility track throughout Cisco Live. That'll be the same in the US coming up in, I think, June. So both those aspects of Cisco Live are coming. And then February 26th, of course, Distributech. So Cisco will be there in a pretty big way. We also have our utility advisory board. That's where we listen to our clients as we direct our roadmap over the next 1 to 2 years. And so if you're interested in being involved in that, you'll see the note here to reach out to us through Contact IoT. So with that, I'll close and thank you everyone for joining and having a conversation around SD-WAN, security, and how that's fitting into the OT space. And then, the double click around the validated design that Marcus's team has done specifically in the DER landscape. And then finally, our last poll here is if you'd like to be reached out by some folks on our extended team, just indicate so in the poll. As you close up your WebEx, you'll get you should get a poll. Provide us some feedback. We're always looking to iterate and improve how we provide information out to the field. So thank you everyone for joining, and have a great rest of your day.